This is the BIQU BX that is currently available as part of a Kickstarter campaign. And today we're going to take just a little closer look. Hello everybody, Chris here, and yes, just a little while ago we did a live stream unboxing the BIQU BX, and we did have a few issues. So in this video, we're going to see what those issues were and how I got around them. Also, we're going to take a general look at what you can expect if you back this printer. What kind of items will be included, what the main board looks like, power supply, the works. Now it is important to mention, this is an early release unit. So the problems that I experienced will probably have been long since fixed by the time you receive your machine. So you shouldn't have to worry about these kinds of things. I know they are currently working on the firmware to make it even better. So I'm just going to show you what I encountered, what we did to resolve it, and you shouldn't have to worry about this, but it might be helpful in case you have problems down the road. So let's jump right in, take a look at a few issues, then we'll move to the fun stuff. So the first thing that we noticed when we booted up the printer is the touchscreen appeared to be non-responsive and it was doing some strange things. So I wanted to take a closer look to see if we could remedy that. Hopefully it isn't just a bad screen. So I wanted to take the bezel apart. There's just 4 screws holding it on this metal plate. And once that's been removed, I want to go ahead and have a look underneath this bezel that's actually attached to the screen. Most of these just have some tabs that run through, they fold them over. You can usually flatten these out and pull that bezel off. Hopefully you never have to do something like this, but I'm just trying to troubleshoot to see what's going on here. With all of those tabs folded straight, you should be able to just slide this off. Be careful. And we got it off, and the first thing I notice is this issue right here. Now, I thought during the live stream that this was just a piece of plastic that got left on that may be causing it not to trigger. But they installed the bezel while this wrapping was still on, and it went all the way to the edge. So that might be the first problem. So let's just peel that off. And something I also noticed after the live stream is these 2 ribbon type cables back here. The latches that hold these pins down, both of them are still lifted up. They didn't get seated properly. So we're just going to make sure that both of these cables are as far in as they need to go. Don't use a lot of pressure if you want to adjust those. And we're going to force both of these latches down. To confirm that those latches are seated properly, they need to be flat with the connector. You shouldn't feel a raised section. They should be all in one. Now, with those 2 changes, let's put it back on the printer even before we put the bezel back on and see if we can get it running. And we're booting back to touch mode. And now let's see if the touch works. Let's go into menu. We have success. So probably with that plastic being on there, that probably shouldn't hurt anything, but those latches being up definitely made some pins not connect correctly and our touch mode didn't work. We have corrected that. So let's put our bezels back on, get it on the printer, and I'll show you what the other thing was that I saw during the live stream. So now that we got the touchscreen mode working, I don't see the same issue that I did on the live stream. You might be able to see it, what was happening during the live stream, but every time I try to go into another mode, you can go into Marlin, Raspberry Pi, or the touchscreen one right here. I would hold this button for 3 seconds to issue the menu, and then as soon as I would get to this menu, the whole printer would reboot. Now I should be able to go into the menus freely. I don't have the RPi installed. That will be on another video very soon. But I can go into Marlin mode freely. And then I can come out of Marlin mode and go back into touchscreen. No problem. Before we corrected the screen, it would reboot every time I tried to do that. But the feature that it was trying to use, let's jump back out, is every time that you come in and out of RPi mode, it reboots that Raspberry Pi. And that's what we were seeing. It cycles the whole printer as you get into that mode, so you don't have to have it powered all the time. So that is a feature that we're going to be looking at more when we do the Raspberry Pi install, but I'm just interested in these 2 now, so we'll work with those from here. I'm going to consider this corrected. So we were able to fix up the touchscreen. It looked to be just a few loose connections, and everything's working properly now. So that's a relief. But now I want to move on to auto bed leveling and the issues we saw. And mostly it was because of the probe offset. It's probably going to be a little bit different printer to printer, but let's walk through how to get that corrected. So again, the main issue here was that the inductive probe wasn't set correctly for the height of the bed versus the nozzle. And we can just go and redo that. During the live stream, I just unhooked it and pushed it up so we could get it out of the way, but it was actually bottoming out on the bed, so I couldn't even use baby stepping to get the nozzle height correct. Now you can use your screen in both Marlin mode and touchscreen mode to make these updates we're going to do. You can go to configuration, and probe Z offset is the one that I'm most concerned about. We're going to have to make an adjustment there. But I think it's way easier to show you how to do this through a terminal like pronterface. Plus, there's a lot of glare on this screen. You can see I have it kind of awkward just to keep you away from the light. It's kind of hard to see. So we're going to cable up USB. And just a heads up, if you are cabling up USB, this one uses USB-C right here in the front. That's the connection you're going to want to use. So we're going to open up pronterface. If you don't have it, there will be a link in the description, and you can just hit connect. More than likely your baud rate will be 250,000, and it already knows your COM port if you've already plugged it in. So just hit connect. And the printer is online. The first thing I'd like to do on all of these printers is just take a look at what is in EEPROM. These are the settings that have been pulled into EEPROM or may be changed from the original code load. So we're going to do M503. And you can see all the settings. It even gives us all of our G29 probe points that we made earlier, even though I have auto leveling off right now. The ones we're really concerned about are these M851 settings. Primarily that Z-1.3. We're going to have to make some adjustments here. So the first thing we're going to do is home the printer. Then I'm going to move the X over to the right, just somewhere in the middle, but you can still adjust that probe. And we'll move the bed just a little bit to the front. So we have a good spot where the nozzle should be level at 0. Now, if you do an M114, this will tell you where you are currently. You can see we're at a Z1.5. And that's pretty usual for when you do home, that it's going to lift the Z up, so you make sure not to rub the nozzle on the bed or crash into anything. So now I'm going to turn the printer off. And while I'm going to try to keep the Z screws as even as possible, I'm just going to bring the carriage down so the nozzle rests on the bed. Not so much that it's pressing on the bed, just sitting on it. And we were only about 1 millimeter off, like we saw in M114. Now the starting point for one of these inductive probes, most of the time it's around 1 millimeter. I find that a small zip tie usually does the trick. So we'll just set our zip strip underneath the probe, and then we'll adjust the nuts on the probe to bring it down to touch it. So again, make sure your nozzle is on the bed over here. The probe is resting on the zip tie. Make sure the probe is as vertical as you can get it. You don't want any slopped left or right. And then we'll snug up that bottom nut, just to give us a placeholder. So we're good there. We're still on the zip tie. And then we'll snug up that top one to make sure it doesn't go anywhere. And there we go. Now, it's a little bit over 1 millimeter high. You might have to come back and make a quick adjustment. But let's start here and see what that gets us. So we'll turn our printer back on. It is important to note that this design, they use a Z end stop over here for homing. And the probe is just for leveling. So our Z offset is only going to affect our G29 moves. After you run a G29, it will be in effect, and then you can start printing. And from there, if you need to make adjustments, baby stepping should work in our favor. So back to pronterface, I'm going to go ahead and connect again. I'm going to heat the bed to 60°C. Now I'm going to go ahead and tell it to go home one more time. And then we're going to run a G29 to tell it to do an auto level. By default, this machine has 25 points. And it is a little bit slow. Hopefully they update that. But let's let it run. You want to make sure the nozzle isn't going to crash when it's trying to probe. That means the probe is too high. All the probes that I've seen so far, we should be in good shape. After all the probe points have been complete, I'm going to lay a piece of paper down. Then let's move to the center of the bed. Let's just tell it G1, X125, Y125. That gets us kind of close to the center. If you do another M114, we are 6.42 on Z. Let's move Z down to 2, G1, Z2. Let's check our paper. We still have clearance. And then we can use our dials over here. We do have a 1/10. And move the nozzle down just so it starts gripping the paper. On these powder coated sheets, I do like to make them a little closer than on the smooth sheets. So after a few clicks, I've started to grip the paper. We can M114 again. And we're setting at a Z 0.9. That is your new offset. So we'll do M851, Z negative 0.9. Now again, we can adjust this with baby stepping on the fly if we need to, but this is going to be a great starting point. And it's in the negative because the sensor triggers 0.9 millimeters before the nozzle reaches the bed. That's how much higher it should be than the nozzle. So we got pretty close to our 1 millimeter at a distance. So we'll go ahead and hit enter on that, and then we'll save it to EEPROM with an M500. You can take another look with M503. Here's our 851 with our Z at 0.9. Now from here, I just like to run a test print to make sure that it's set correctly, and then I'll dial it in with baby stepping. And I still like to use Tom's bed leveling pattern. I'll leave a link in the description, but let's just give it a try. And remember, in your custom G-code, your start G-code, to use that auto leveling, you do need to add a G29 command to get it to run that sequence. So I just loaded on the SD card, now we'll give it a go. And I would say that our first layer as it goes down is just a little low. Remember, I did set it pretty tight because of the powder coated sheet, but you can always adjust it. So double click while it's printing, and that will take you to the baby stepping adjust. We can back it up just a little bit into the positive. I jumped up 1/10, and that looks a lot better already. So maybe negative 0.8 was a little better setting for us. Just remember, with this firmware setup, you can adjust it on the fly and then make your updates to EEPROM as you see fit. So we'll go with this for now. I'm pretty happy with that. And if you want to make your adjustments in EEPROM and save them after you've done your baby stepping, so it will be the same every time you boot and print, just adjust your Z offset. Again, M851. And let's go with Z negative 0.75. That should make our first layer look a lot better. Then save again, M500. And another quick tip, if you do have to make adjustments to get the nozzle down to the bed, you might have skewed your X gantry just a little bit. Meaning if one of these motors is higher than the other, it might skew the X just a touch. And because there's only one end stop, it won't correct it on its own. So what you can do is use that level map to try to adjust it. When you open the terminal and run that G29, it's going to give you this map. You can see that the left side of the bed, right here at 0.361, is just a little bit off from the right side at 0.224. So manually make adjustments to either the bed screws, which this one has. If you're using auto bed leveling, you might want to consider bottoming those out. But this should let you make adjustments to those two Z motors. So in this case, I would probably adjust the left one because that's the one that doesn't have the end stop. The one on the right should correct itself when it triggers that end stop. So bring that side down a bit, rerun your G29, see what the map looks like, try to get those as even as possible. This makes it a lot easier to do than just trying to eyeball it. The other issue we saw during the live stream is we were having a bit of an inconsistent extrusion problem. We fixed it on the fly with temperature and flow rate. We at least got it a little better. And we were able to get a model print that didn't have any stringing, so that's good. But you can see right here where it's shinier, that was where we had the higher temp, then we switched to a lower temp. and we adjusted the flow rate a bit to improve it even further. But if you're seeing this on your machine, the first thing I would do is check and make sure the E-steps of your extruder are set correctly. Now you've probably seen people do this a million times, so I'm just going to hit the highlights here. But basically what you need to know is that if you ask your extruder to extrude a certain amount of filament, you want to make sure that you're getting that amount. And the easiest way to do that is to just measure your filament with your ruler. So from the top of the extruder, I like to measure off 150 millimeter, and then measure it again after I extrude 100, and it should be 50. Again, I like to do this in pronterface. I want to make sure that it extrudes it really, really slowly. You can do it from your screen, but in pronterface, go to Settings and Options, and your manual feed rate, this is done in millimeters a minute. I just set mine all the way down to 100. That is really slow, but that will get you a more accurate result. And then once you're up to temp for the filament that you like to use, just set this to 100 here and hit extrude. And then from your filament marked, go ahead and remeasure it and make sure you're close to that 50 mark if you marked at 150, or whatever measurement you want to mark it at. Once you have your new value, back to the terminal. Again, this setting is available on the screen. All these motors have a 0.9 degree angle, so your steps are going to be a lot higher. And that's okay, but we just need to make the adjustment as follows. The default setting on my machine was 950. I like E910 a lot better. So we're just going to do M92 E910, and that should solve some of our extrusion issues. And just to give you an idea of the accuracy of a thermistor on this type of machine, I have it set to 210 degrees right now. I have the probe down at the nozzle and it's reading 218. Now this is actually pretty accurate for one of these machines, believe it or not. 8-10 degrees either way, that seems to be pretty normal. But just keep that in mind when you're tuning one of these. If you think you're at 210, you might be lower or higher. So depending on the filament, you might have to tune that in with a temp tower or something like that. These thermistors aren't the most accurate things in the world. Just a side tip. And again, any changes you make, you want to save with an M500, so there'll be an EEPROM after each reboot. And there are a lot of things you can do to help your extrusion, but that's the first one that I would check for sure. But a lot of these things are going to be inside the slicer, and I will leave a link in the description to the semi-tuned-in slicer setting for Prusa Slicer that I'm going to use. Remember, every machine is going to be just a little bit different, and the filament you use has a lot to do with that. Now let's get on to the fun stuff and compare some of the things on this printer with some of the things we see on other printers. So the first thing that you're going to want to check out about the BIQU BX is the extruder. And before we take it off and take a closer look, you will notice it is connected with an HDMI cable. Now they're probably using multiple connectors. There is a board here on the back, and I really don't see an issue with this. It should be able to handle all the current that are needed for the parts on the extruder. But I'm hoping that this is a sign that there will be more tools available and you can swap them out. So we'll see what happens with that in the future. Now let's take a closer look at this extruder. Here's a closer look at it. You can see the tool board on the back. Basically, it's just all the connectors that you need to get to that HDMI connector, but your part fan's back here as well, so the duct is in the back of the nozzle. Now to remove the whole motor assembly for the extruder, you would have to remove these boards and this fan to pull some screws and get it off of there. But if you're careful, you can just remove the extruder portion. You can leave the motor intact. And here's what it looks like inside. You have a smaller gear rotating a larger assembly. You are stepped up once again to even a larger gear. This is the gear you can see out in the front. All of these are metal parts. And then you have your idler arm with the other side of the filament gears that just slips on top of that. And if we set that assembly aside for a second and take a look at the E3D Hemera, you can see the one that they use on the BIQU is much smaller, but how do the insides of the Hemera compare? A similar type of design, you do have your small gear on the motor shaft, but they do it in one less gear. The motor drives this single larger gear, and then that assembly houses one of your filament drive gears and meets up with your idler arm to create that dual filament gear setup. So it's somewhat similar to the Hemera, but the Hemera is actually a little bit simpler than the BIQU Extruder. And they both do have kind of a cool heat sink. This is the BIQU, this is Hemera. I think the Hemera is still just a little bit cooler looking, and you can't tell me that doesn't resemble Sanjay's haircut. So the BIQU assembly, the gears are stacked just like this, and then you can put your heatsink over it as a cap that has your idler arm. So the heatsink just sits on like this. We have two longer screws that go into the motor, like so. Then the hot end fan sits on top. Then we have a guard and a couple of screws to hold the fan on. And that's all there is to that assembly. Something to look out for if you do get a BX, the sheet that they give you, the magnet isn't really strong on here. I don't know if they intend to change this up at some point. It does stick the sheet down. I haven't had any issues with it while printing, but it's not the strongest thing out there. So be on the lookout for that. But now let's take some of these covers off and just see what the electronics are like. On this side we do have a Meanwell power supply. It is an LRS 350/24, so 24 volt. If you've ever messed with the Meanwell, you know they have fans and those can be kind of loud. Not a huge issue, just something to be aware of. And then on this side, this whole thing can be separated. It also has some covers you can get to from the top, but I'm just going to pull the whole section off. Then I'll remove these 4 top cover screws. And inside we have our main board. Now this one is marked as an SKR SE-BX, so something designed for the BX printer. You have screw down power lugs, you have a squirrel cage fan, a blower fan to cool it off. You also have a smaller fan here in the front. You have 5 replaceable drivers. These are marked as 2226s, which are rebadged 2209s. Replaceable fuses. You do have a large heatsink for your processor. Looks to be a port for a Wi-Fi module you might be able to add later. And down here at the bottom, it's kind of hard to see, there's an RJ45 Ethernet jack as well. So maybe some more functions that are coming. You don't see a lot of things plugged directly into the board. That's because they're being fed into this HDMI jack via that cable. As well as this large port down here where it gets all the information from that screen. Something I did also want to mention before I put it back together, the power supply is actually grounded to the case. You can see it right here. So that's pretty much all you need to know about this 3D printer. Everything else is just like a lot of the other printers in this class. This one does have a few added bonuses. You get that type of extruder. You do get belt adjustment. 32-bit board, of course, Meanwell power supply, and the 7-inch touchscreen. The only other advantage that I see on this one is you do get dual lead screws. They are the standard 4 start that you see in a lot of 3D printers, and I do kind of like this carbon fiber look that they have on the front. And after the changes that I showed you in the video, the PID tune and the extruder tuning, I did also increase the amperage to 1 amp for that extruder motor. It seems like we were getting just a little bit of inconsistency in the layers. That seemed to help some, but you might need to tune that. My motor doesn't get hot, but you might not want to go that high. I'll continue to test. The Benchy does look a lot better. I will continue to tune the slicer because I think we can get it even better than this, but we're already starting to improve. So I think the printer is capable. So there we go. Just a few things that I had to fix to get my BX up and running, and a list of the features that you should expect if you back this Kickstarter campaign. And remember, this is a Kickstarter. Basically, it's just a donation. They don't necessarily have to deliver on their promise. But with a company like BIQU and their reputation, I would expect that it's probably a pretty safe bet. And I did find a few bugs on this machine, but it's important to remember, this is probably not the one that you're going to get. This is a very early model. Most of the bugs I found were around the screen. I had a few reboot issues while printing from the SD card, but I hope that's all been resolved by the time you get your machine. Well, hopefully you liked this one and you found it helpful, and I will see you very soon on the next one.